Hello, ladies and gentlemen. Today we're going to go through a problem on the Hill-Huntington method. Um, this problem is what you're seeing right here on the paper. I'm keeping the camera up there so you can sort of copy it down in your notes. I'm going to have to move this now and take the problem down. So what the problem says is that we have Captain Holt is going to give 225 pieces of candy to his four friends based on the amount of volunteering they did last week. So if you look at the chart below, you can see the amount of their volunteering time, and the time is in minutes. And the first thing that you should be doing on your own is totaling up the minutes. So if you add up the minutes on your own, you get 2,700, and Captain Holt is giving out 225 pieces of candy. So if we divide that, we're going to get our divisor that we're going to be using for the Hill-Huntington method, which is 12. So now what you need to do is you need to take the candy amounts and divide them all by 12, right? So I want to take, I think it was Charles had 871 divided by 12, and Amy had 1,029 divided by 12, and Rosa had 610 divided by 12, and Terry had 190, divided by 12. So Charles's, if we get a decimal for that, we get 72.58. For Rosa, we would get 85.75. Or sorry, that was for Amy's. For Rosa's, we would get 50.83, and for Terry, we would get 15.83. So now we need to round these. So if we're using the Hill-Huntington method, and you want to think about these, when we go to round them, since we're above 0.5, all of them are going to go up. So it's important to remember as you're using the Hill-Huntington method, if we are essentially below 0.4, we're going to round this down. If we're in between 0.4 and 0.5, and really, if you're 0.5, you're going up anyway, so we'll just say 0.49999, right? So this you have to look for geometric mean, but if you are above 0.5, if you're 0.5 or above, you're rounding up anyways. So these will all get rounded up. So if we rounded these up, that would be 73, 86, 51, 16. If you add all those up, you would get 226 pieces of candy. So we're one piece of candy away, right? So I need to lose a piece of candy. So if I need to get rid of a piece of candy, just one, what I would do is say, if my divisor was 12 and I want my candy amounts to go lower, then my divisor has to go higher. And if we just really briefly look at Charles's, which was 871 divided by 12 again, and that got us to 72.58, that was the closest to being like in that 0.4 range. So then we might have to, we might want to figure out what that is. So to find out what our new divisor could be, we need to take our 871 and divide it by the square root of 72 times 73, and we essentially get 12.0140. So we're at 12. We know we want to push that divisor up, and this is how we could find a new divisor. And I still want to have a greater number than 12.0140. So what a good new divisor to pick would be 12.02. If I pick 12.02, I'm going to have a new divisor that I can then check and see what I get. So 12.02 is my new divisor. To sort of round out this problem, what I would do is I would take Charles's 871 divided by 12.02. I would take, I would take Amy's, which was 1,029 divided by 12.02. I would take Rosa, which is 610 divided by 12.02. And I would take Terry's 190 divided by 12.02. Okay? Man, I'll tell you, I wish I had some more board space. So if you do this, you would get out some numbers. So you'd get 72.46. You would get 85.60. You would get 50.74. And then you would get 15.08. Or sorry, 15.88, I believe. I'm going to check that number for you real quick. $190 divided by 12.02. Yeah, 15.80. Sorry about that. This is 15.80. These three, because they're still above 0.5, automatically would round up, right? So they would all round up. So this would be 86, 51, and 16. I want to know what the geometric mean is now. So the geometric mean of 72 times 73. Okay, what's that? All right, so if I took the geometric mean of that, I would get 72.49. So if you look at what we got, our modified quota, and what our geometric mean was, our geometric mean is bigger than our quota, so that means we round down. So instead of 72 pieces, instead of 73 pieces, Charles gets 72. If you add up all those pieces of candy on your own, you would find out it would be 225. So that is hopefully a good summary of the Hill-Huntington method.